Alright, so here's our information. We're going to try and figure out what's the probability that a randomly picked person is going to be male. And so here there says there are 90 males out of 178 people. And so my answer is 90 out of 178. For part B, it says find the probability that someone is male and has paired steers. Well, right here is the number of people who are male and have paired steers, and we still have 178 people, so we got 19 out of 178. Part C says male or pierced ears. So here are the people who are male. That would be 19 out of 178. And here are the people who have pierced ears, which is 103 out of 178. However, I'm not going to add them because these are not mutually exclusive, because some males do have pierced ears. So what I have to do is I have to take off these 19 people who basically got counted twice. So I'm going to add 90 over 178 plus 103 over 178, which if I just added those, it would be bigger than 1. And I would subtract 19 out of 178. So 174 out of the 178 people either are male or have pierced ears, or both. Alright, so in the next problem, it says that there are 52 cards in the deck, and there are 13 cards, and the jack and the queen and the king are referred to as face cards. So we need to make a two-way table with face cards and hearts. So we're going to go yes or no with the face cards, yes or no with the hearts. And in each one of these, I'm going to have my totals. And we know that we have a total of 52 cards. And we know that there are 13 hearts. And that means there are 39 cards that are not hearts, because we have to total those up to be 52. And if we have jack, queen, king, and 4 suits, that means that there are 12 face cards, and therefore there are 40 that are not face cards. So, of the 13 hearts, the jack, the queen, and the king are face cards, so that means I'll put a 3 right there, which means 10 are not. And since this column has to add up to 12, I have a 9 right there, and I'll have a 30 right there, and all my numbers should add up. And so what is the probability that something is a face card and a heart? Well, that's 3 out of 52. And for part B, I'm going to go back to the probability rule I should have showed you before I started this problem, which is the probability of A or B equals the probability of A plus the probability of B minus the probability of A intersect B. So in this particular problem where I want to find the probability of face cards or hearts, we have 12 out of 52 that are face cards, plus 13 out of 52 that are hearts, minus 3 out of 52 that are both. So when I add these up, 22 out of 52 cards will be either face cards or hearts. Alright, this time we're given this setup where Deborah is getting promoted 70% of the time. So I'll put the total of Deborah to be 70% of the time for this two-way table. And since we're given percentages, 1 will be my total, which means that there's a 30% chance that she will not be promoted. Matt's chance of being promoted is 50%, and which means that Matt's probability is not 50%, right there. And the probability that they are both promoted, which means they both got a yes, is 0.3. So now when filling up the rest of this table, I need this row to add up to be 0.7, so 0.3 plus 0.4 is 0.7. I need this column to add up to be 0.5, so 0.3 plus 0.2 equals 0.5. And if I need this row and this column to equal 0.3 and 0.5, that needs to be 0.1. So in part B, if I make these into a Venn diagram, I know that there is a 30% chance they both get promoted. We'll call this side Deborah and we'll call this side Matt. Deborah's circle should have 70% inside, so I put a 0.4 right there. And then, so I did part A before I did part B, so let me call this part A to be proper. And this up here is part B. My apologies. And so Matt's circle has to be 0.5, which means this has to add up to be 0.3 and 0.2 is 0.5. And since all of the situations have to add up to be all of the situations have to be equal to 1, because there's only getting hired and getting promoted and not getting promoted, means that when I subtract the other 3 probabilities that I have in this Venn diagram, I'm left with 0.1 on the outside. So 1 minus 0.4 minus 0.3 minus 0.2 equals 0.1. So in part C, what is the probability that at least one gets promoted? Well, taking a look at the Venn diagram, anything that's in a circle are people getting promoted. So that turns out to be 0.9. For part D, what is the probability that only Matt gets promoted? Well, that is this right here, which is when Matt gets promoted but Deborah does not. 0.2. And E, what is the probability neither one of them gets promoted? That's on the outside of the circles, which is 0.1. One more of these. We'll do USA Today up here, and we will do New York Times over here, and either your yes or no. And your yes or no. So if 40% read the New York Times, that means 60% does not. Sorry, that USA Today. And 25% read the New York Times, which means 75% do not. And 5% read both papers, so I'll put that in there. And so when I have to add this up to be 25%, that's 0.20 plus 0.05 equals 0.25. When this column needs to add up to be 0.4, that's 0.35. And then when these two have to combine, 0.4 works for both the row and the column. Alright, so USA, or both is 0.05 for the middle of my Venn diagram. Since 25%, what's called this USA Today and this New York Times, since 25% of people read the New York Times, that circle needs to have to 25%, so that's why I put a 0.2 in there. And 40% read the New York USA Today, which means I need a 0.35 in there. So 1 minus 0.35 minus 0.2 equals 0.4, which gives me the outside. And that's the Venn diagram. What are the chances that a resident reads at least one paper? 0.35 plus 0.05 plus 0.2. All the people in here, which turns out to be 0.6. That's C. And for part D, we already have the answer on the outside, which is 0.4. And that is this particular lesson, 4.5-2 on two-way tables.